Hello everyone! Manufacturing execution system software is a large and complex system. The name itself speaks for what it does. We've already dedicated several episodes to this program, and as you've probably noticed, I cover each function in a very focused way. Every production process is unique. It's multi-layered, multifunctional, multi-directional, and so on. The system we are exploring in this series aims to cover all aspects related to production processes. I won't repeat what we've already covered. If you've been following along, you already know the basics. And if you haven't watched the previous episodes, you can find them all on our channel in the playlist in order. This topic is definitely not for everyone. If you are not interested in diving into such a large and complex subject, for example, if your work is focused only on a narrow specialized tasks, then this may not only be uninteresting but also difficult to understand. I don't mean to offend anyone, but this area involves many specific domains such as accounting, logistics, management, production control, and personnel management. And of course, in every case, it also requires a deep understanding of the production process itself. So, if you are not connected to this yet, or haven't encountered it in your work, you can simply skip the MES topic. This topic is for those who are already ready or have been placed in a position to solve complex, multi-layered problems like this. And I understand that this MES section is aimed at a fairly narrow audience, people who are at the top of the pyramid and are able to grasp the full scope of such systems from that level. Today, I'll focus very concisely on several key areas of production management: assigning tasks to personnel, monitoring task assignments, working with the calendar, and archiving both assigned and completed tasks. I'll also briefly go over some system-level functions. And as I promised in previous episodes, I will show you the architecture of our program. I'll open my development project. While working with different features, I noticed a few typos, so I'll fix them live. Recompile the program, create a new installation package, generate a code signing certificate, and upload the updated version via link in the video description below. Anyone will be able to download this program and try it out in practice. It's completely free. So why is it free, you might ask? Very simple. The reason is that when a company decides to implement our system, it will still require more development like customization, modifications, extensions. Every business is unique. It's impossible to account for everything in advance. It's like a Christmas tree. Without decorations, it's just a tree. But once you add ornaments, it becomes a real Christmas tree. So in this analogy, your ornaments are your custom features added to our base system. That's why the answer is the program itself is completely free, but it's designed to be extended, modified, and improved. It can be implemented in any form, as a desktop application, a web application, a subscription model adapted to specific hardware, displays, and so on. I've already talked about this before, so I won't repeat myself. So today we'll wrap up the MES section. And honestly, I'll breathe a sigh of relief. Because believe me, this topic is complex even for me. It's very multi-layered and mentally demanding. After this, things will become much easier because I won't have to deal with questions like, did you consider this or do you know that? Because MES, in a way, covers everything. If a question exists on the programming level, it will inevitably appear within MES, and it already has a solution there. You know, when you're creating something and people question your competence, it can be frustrating. You feel the need to defend yourself. But I've solved that for myself now. From now on, I'll simply redirect critics to this MES section. And a brief announcement. We're getting close to the point where we actually earn money using our knowledge. It would have been strange to start with that from the very beginning. We need this foundation first. Now that we have this knowledge, all that's left is to implement our ideas, and we'll be doing that using tools from National Instruments. Of course, you can use other tools, but I personally chose National Instruments because it allows you to build and deploy solutions quickly and efficiently. Now I want to show you a page on our website, laplanda.com. This is where we will learn how to monetize ideas, test them, and understand whether they are in demand. And if they are, we can assign our own price to these ideas and projects. At the moment, I live and work in Silicon Valley. On this channel, I focus only on technical topics. I don't really talk about social life or the broader ecosystem and opportunities here, but I'll give you just 2 numbers so you can understand the potential of this place. The data is a bit outdated though. If you want the latest numbers, you can always look them up, but even this will give you a sense of the scale. The volume of investments directed into China, specifically global investments, amounted to 15% of all worldwide investments in 2020. At the same time, for this tiny piece of land located in California in the San Francisco Bay Area, known as Silicon Valley, that figure stands at about 20%. Therefore, the figure you see on our page, $1 million, is, of course, the starting point for a startup founder's dialogue with an investor. On this page, you can read about how to apply. I will now briefly run through the sections featured on our website, Laplanda Project Bank. I won't open them up, but will simply outline them. So here you see sections like technology, automation, education, bioengineering, security, custom add-ons, startup applications, and even real estate. If you already have ideas or projects ready for development, they can be placed in one of these sections on our platform. We have a group of both known and anonymous investors who periodically review these pages, and mysteriously, some projects disappear from these pages over time, which means they've likely been picked up for development. At the same time, new projects keep being added. Now, as a preview, I'd like to focus on the startup applications section. I'll leave the link in the description. So what do we see here? We see many templates that are already created, as well as many templates that have been requested but are still in development. What is a template in our case? A template is a web application concept. It contains an idea that is not fully developed, but it demonstrates the key directions or solutions to a problem. These templates are sold at a nominal price of $100. If someone becomes interested in developing the idea further, expanding it, improving it, or fully building the project, that's essentially the beginning of a startup. If you're watching this right now, chances are you already have ideas, so why not to take on this opportunity? Now about the announcement. Starting from the next episode, I'll begin a large section on web development using resources from National Instruments. You won't need to know traditional text-based programming languages. The IDE will handle that for you. It's an intelligent development environment that takes care of the technical layer. Your role will be to create architecture, logic, design, the purpose of your application, of course, and its scalability, especially from a monetization perspective. All of this can attract potential investors. And in the upcoming episodes, we'll cover how to do it better, how to do it more effectively. So make sure to subscribe so you don't miss it. Now I return to the MES topic, log into the system as the administrator Bill, and today we'll look at the task function. First, let's clarify how tasks differ from operations. We explored operations in the previous episode. An operation is a functional task assigned to an operator, whether a person or a machine, a robot, that does not change during the production process. It's a routine, repetitive activity performed on a regular basis. For example, assembling a stool or painting it, like in our examples from the previous episodes. A task, on the other hand, is something different. A task is a non-standard one-time assignment addressed to a specific employee. It has a deadline, and it also allows for discussion, reassignment, or delegation to another employee. This task will appear in the employee's calendar and on their dashboard. Now I'll create a task. Actually, 2 tasks. For example, for Ashley. Let's say I'm Bill and I'm assigning a task. I won't go into detailed description here, I'll just enter some random text. The goal is simply to create the task so we can see how it appears to Ashley and how it gets recorded in our MES system. So, let's create a task for Ashley. Report to Bill. For the task name, I assign a number, for example 701, then I fill in the required fields. Description, goal, and SOP, standard operating procedure. Next, I specify lot ID and lot description. These are production-specific fields, which can include numbers, codes, or any relevant identifiers. In the notes section, let's add a comment. For example, this task should be done in 3 days. Then let's define task resources, the resources needed to complete the task, and also fill in parameters, including lot parameters. After that, I click Assign. Okay. Now we see task request number 701 successfully created and assigned by Bill, assigned to Ashley with reporting back to Bill. Also notice on the left side of the user interface, Ashley has received a notification message that a task has been assigned. Now let's quickly create a second task. Again for Ashley, reporting to Bill. This will be task number 702. I won't change much, just set a different deadline, for example 5 days. And add a small variation so it's not identical. And that's it. Now we've created 2 tasks for Ashley. Now let's log in as Ashley.
Task report.
And in the task list, we see the 2 tasks that were just created, 701 and 702. I select task 701 and we can see all the details that Bill entered when assigning it. The same applies to task 702. Ashley reviews her tasks, completes them, and can add comments in the notes field. After that, she sends a report to the person specified, in this case, Bill. Before sending the report, let's check the calendar. For that, we need to log back in as Bill, since only he, as a manager, has access to Ashley's calendar. We go to the task calendar and select the task. Here we can see which tasks were assigned, to whom, the assignment date, and their status over time. Since Ashley hasn't completed the task yet, the date, for example October 23rd, is highlighted in red. Now we go back to Ashley. She opens task report, selects task 701, adds notes, clicks send, and submits the report. Both tasks are now completed. We return to Bill, go back to task calendar, and select task 701 again. Now the date is no longer red, it's highlighted in green, which means the task has been completed. At this point, Bill can move the task to the archive. We go to task archive, task request move to archive, and here we have filtering options to manage tasks efficiently. We can view all records or filter by, assigned to, or report to. This becomes especially useful when there are many tasks in the system. We select task 701 and click Move to Archive. Move record to archive, OK. Done. The item has been moved, so the task is now archived. In general, it's clear that the task creation and execution function is extremely important. In real production processes, new requests appear constantly, daily, hourly, even every minute, and handling them through regular messengers is not efficient. Especially since, from the beginning, we agreed not to rely on external tools like email, Microsoft Teams, or others. A task needs to be structured and standardized. This not only simplifies task creation, but also makes it much easier to understand. Because if tasks are given in different formats, and especially by different people with different styles, it can be difficult to even understand what is expected of you. But when we use a standard template, it prevents ambiguity. It eliminates unnecessary creativity, unclear wording, or non-standard approaches that might confuse the performer. It's also important to note that task creation is a managerial privilege. Not everyone should necessarily have access to it. At the same time, the ability to execute tasks should be available to everyone. So hopefully the concept of tasks is now clear. Next, we move on to another important area, system functions or system data. We go to Work, System Data, and here we see the full list. Naturally, system-level functions are not available to everyone, only to users with high-level administrative privileges. Let's take a look at what we have here. The first function is Save Path for Logo. This allows you to replace the logo in the GUI of the program. To do this, you simply paste the file path to the logo image stored on your computer and click Save. The next function is Save Path for Front Image. This lets you replace the main front image of the interface. Again, you insert the file path and click Save. To see the changes, you need to restart the program. Click Exit, then open it again. And now we can see the updated interface. And it looks great. After that, I restore the original logo and front image by going back into System Data. updating the paths again, and restarting the program. Done. Next function, load spreadsheet from file. Here we can load data from a file. I already have a path prepared, so I insert it, and immediately we can see the data from that file displayed in the table. The next function is save table to file. This allows us to save any changes we've made either to the same file or under a new name. For example, I can edit something in the table, save it, and then when I open the file again, I'll see that my changes have been successfully stored. Next, save database backup destination. This is for setting the location where database backups will be saved. Pretty straightforward. Then, save SOP credential. This is used to store credentials related to standard operating procedures. And finally, users' passwords and access. We are already familiar with this section. We've used it multiple times to assign roles, modify permissions, and add new users to the system. Next, alarm reference. Here we assign either a local host or a remote server where the global variables for our internal messenger will be stored. Printer settings. This is where we configure the printer. Company information. General company details. Here you can edit, update, or add information across different fields in the system. Company ship to. Similar functionality, but specifically for the company's shipping address. Next, sales tax. This is where the sales tax is configured. Structure list. The company structure list. We can update or expand it if needed, and then save the changes. And finally, task print report. This is used to configure how task reports are printed, including the header and the website link that appears on the printed document. Next, MES Access database username and password. Here we set the login and password for accessing the database. Inventory storage. This is the list of our warehouses. We can expand this list and add new storage locations if needed. Organizational structure. Here we can view and work with the company's organizational structure. Configuration file path. This points to the configuration file, typically config.ini. Database instruction. This defines the path and instructions for connecting to the database. Database information. Here we can view the actual data stored in the database. By clicking Show, the data appears in a table within the user interface. Database properties. This includes technical details such as the connection string and timeout settings. So, very briefly, that covers the system functions. My goal here is not to fully teach how to work with MES, but to demonstrate the scope of its functionality. As I've mentioned before, the system is quite extensive, and despite the simplicity of the user interface, it provides a very powerful and comprehensive set of features. In this algorithm, a special logic is used without traditional pages. Instead, we see a dynamic interface where not only tables, colors, and windows change, but even the purpose of the user interface itself can change. For an operator, it's one type of interface. For a manager, another. For an inventory specialist, a different one. Once again, I want to emphasize this is a template. It's greatly simplified and designed to be adaptable to almost any production environment, with an unlimited number of operations. The design, screen resolution, and even the deployment type can vary, whether it's a desktop application installed on a computer or a web application. Also, I just noticed a couple of typos in system data, in Save SOP credential, and in database properties. I'll need to fix those. To do that, I have to open the source code because it can be corrected directly from the interface. I'll need to make the changes and recompile the program. I haven't really spent time explaining how this works at the programming level, but now we'll take a look at it as well. Now I'll open my project and show how everything is structured. Here we have the project files. These are the main components of the system. I also have additional files. In the sub-vi folder, I store all the functions that I use as objects. If we open the properties, we can see there are quite a lot of them, 274 files. You can browse through all of them. Many of these functions were created from scratch in the episodes about the database tool. There are also many unique functions here. In general, when developing a program, most functions tend to be unique because every program itself is unique. In the data folder, I keep supporting directories, including folders for the database, SOP files, and add-ons. Let's open the config.ini file. As you can see, many elements here are encrypted. We already covered in detail how and why this is done in the previous episodes, in our first playlist to be exact. Now I open my project On the block diagram, I need to change true to false for the quit LabVIEW function. I won't go into detail here since we've already covered this before. I run the program and locate the issue. Work system data save SOP credential. Here is the first typo. I press the red stop button on the block diagram, fix the typo, run it again, stop it once more, and correct the next one. Now I have to save the project several times. The first save stores the current state of the interface and layout. Then I do save all this project to save the entire project. I run the program again to verify the fixes. Now I see save SOP window if empty, correct. Database properties, default database, also correct. So the typos have been fixed. Next, I exit from the front panel and switch the value back from false to true on the block diagram. Then I save everything again and close the front panel. In the project, I open the build configuration, build specifications, Laplanda MES SQL Connect. I quickly check that everything looks good. Here I see that I need to change the icon image from 16 by 16 to 32 by 32 so it displays properly. After that, I know everything else is fine, so I go ahead and click Build. At this point, the program is being compiled. As you know, compilation is the process of translating my graphical program into machine code. It's important to note that all functions are written in C++ and exist within my development environment as objects. That's why we can be confident that the program will be highly optimized. The development environment itself handles everything. It selects the most efficient ways to generate machine code, minimizes memory usage, manages resource allocation, and handles processor communication, the so-called kernel-level interactions. All of this is done automatically, and that's exactly what frees me from having to learn and deal with a huge amount of low-level technical details, which in this case are simply not necessary for me. Now the system prompts me for the password to my code signing certificate provider. I enter the password and assign the certificate to my file. At this point, the file is recognized by Windows as trusted and safe, meaning it installs without warnings or additional security prompts. I save the project, and now we can say that we've created the executable file that can be installed on a computer. However, the executable alone is not enough to run the program. We also need a full installation package, including supporting files and the application shell. I showed these components before. So all of this needs to be bundled together into an installer and compiled as a complete package. I already have installation settings prepared. I open them, quickly check everything. And since there are no changes needed, I click Build again. Now I have a ready-to-use installation file. I'll compress it into a zip archive, upload it to my server, and provide the link in the video description. You'll be able to download it, unzip it, and install it on your computer. At the beginning of this episode, I talked about some use cases of our MES software. And in the first episodes about MES, I also showed how to connect the database. Finally, let's save the project. Well, that's where I'd like to wrap it up. However, let's not put a full stop to it. Let's leave it as an ellipsis. Perhaps we will return to the topic of MES someday. Never say never. If you followed this entire section from beginning to end and understood the core idea, then you can confidently position yourself as a specialist in designing and automating production processes. In the next episode, we'll move on to a very big and exciting topic, where we'll finally be able to apply all this knowledge and start making money from it. And that's all I've got for today. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.